Hello and welcome to the Alaska Ocean Acidification Network's Ask a Scientist series. This series answers questions from real people like you with the help of ocean acidification experts from the network. My name is Darcy Dugan, and our question today is, does Alaska have natural factors that worsen or mitigate ocean acidification? And here to help us is Claudine Hauri, a chemical oceanographer at the University of Alaska Fairbanks. So I'll turn it over to you, Claudine.
Hi everyone, and thanks for having me, Darcy. I was tasked to answer the question, does Alaska have natural factors that worsen or mitigate ocean acidification? The short answer to this question is rather simple, yes. There are several natural processes that can worsen or mitigate the effects of ocean acidification. But to answer this question in more detail, I would like to take a step back. As a little refresher, ocean acidification is caused by the uptake of carbon dioxide into the seawater. The process reduces pH and the concentration of carbonate ions. And carbonate ions are used by certain organisms, such as crabs and clams, to build their skeletons and shells. So even though carbonate ion sounds a little scary, it's basically just building blocks to construct houses or bodies for clams and crabs. And one other thing that you shouldn't forget is that ocean acidification is a global process, which means it happens everywhere. However, levels of pH and carbonate ions and the rate at which they change are different from region to region.
Do we know the rate of ocean acidification in Alaska?
Well, interestingly, ocean acidification has not yet directly been detected in Alaska, so we don't really know the rate yet. But that does not mean that ocean acidification is not happening here. It just means that scientists don't have enough data over a long enough time span in order to distinguish between the natural variability and the human-made ocean acidification. We, of course, can detect low pH or corrosive waters. However, we do not know yet if this is fully attributable to ocean acidification or whether such conditions may have already existed before humans started emitting carbon dioxide.
Why is ocean acidification so hard to detect?
Well, ocean pH and carbonate ion concentrations don't just change because of anthropogenic or human-made carbon dioxide. Physical, chemical, and biological processes naturally change the ocean's carbon chemistry on a day-to-day, seasonal, interannual, or even longer time scales. So understanding the natural variability of a system can help you determine when the long-term trend of ocean acidification may become detectable in your specific region. So for example, NOAA scientist Adrian Sutton and colleagues predict that you need about 16 years worth of high-resolution data in order to detect ocean acidification in the Gulf of Alaska.
Are there natural processes that mitigate or exacerbate the effects of ocean acidification?
Yes. So for example, strong phytoplankton blooms in late spring and early summer suck carbon dioxide out of the surface water and thereby increase ocean pH and carbonate ion concentrations. In effect, this temporarily counteracts ocean acidification. On the other hand, the phytoplankton die at some point and some of that material ends up sinking down into the dark subsurface waters below. Here, this material gets converted back into carbon dioxide and thereby worsening the effects of ocean acidification. But it's not just biology that matters. Circulation can also play a role. Later in fall, for example, currents bring waters rich in carbon dioxide into the nearshore regions, further driving down pH and carbonate ion concentrations in these locations. Another example is that freshwater from rivers and melting sea ice and glaciers is worsening the effects of ocean acidification. Freshwater essentially dilutes the carbonate ion concentrations in seawater. So due to the warming climate, Alaska's glaciers are among the fastest melting glaciers on Earth, thereby releasing much more freshwater into the Gulf of Alaska than they used to. And the increasing rate of freshwater input is likely going to increase the rate of ocean acidification. Here at UAF, my observational and modeling projects focus on figuring out what role all of these different processes play in the progression of ocean acidification and its potential impact on Alaska's marine ecosystems.
Thank you, Claudine, and thanks everyone for listening to this edition of Ask a Scientist. If you have a question for Claudine, please feel free to email her directly, and we'll see you next time.